Hello everyone, we are from PPTI 15, consisting of myself, Alexsandro, and my friend Louwis Steffo. We are honored to have the opportunity to present the result of our research today at this very prestigious conference. The result of the research that we will present are entitled DDoS detection using hybrid model in machine learning. Yeah, this is our member, consisting me, of myself, Alexsandro Ardian, and Louwis Dermawan. So in this presentation, we will thoroughly discuss several key topics, including introduction, literature review, methodology, experiment result, and conclusion. Let's begin with chapter 1, where we will provide context regarding the background of this research. So the first challenge to be faced in the digital era within the context to network security is the increasing internet usage, with the affect nearly all aspects of life and heavily relies on this technology. As technology advanced, challenges in network security also become more complex. One of which of one of which is distributed this denial of service or the DDoS attack, with the various type of the DDoS attack, such as TCP flood, UDP flood, HTTP flood, and other attacks targeting network protocol like TCP, UDP, ICMP, and DNS. We are driven to develop a detection system utilizing machine learning. Okay, there are various methods for detection DDoS attack, one of which is using machine learning, such as the logistic model trees or LMT. Model that combines logistic regression and decision trees with high accuracy. This research aims to explore the latest method using the LR trees model, a hybrid model that combines LR or logistic regression, uh, RFC, random forest classifier, and extra trees classifier or ETC, where the final prediction is based on the most frequently predicted class. Okay, after understanding this background, research questions arise, such as what are the new and effective machine learning models for detection DDoS, and are traditional machine learning models efficient? Okay, let's move on to chapter 2, the literature review. In this chapter, we will examine several, previous studies related to our topic. Three of them are as follows. Okay, the first literature reviews. The first literature review is titled Neural Network Architecture for the Detection of Synth Attacks in IoT System. This study faced the problem where the training data use was artificial data created by bots, and the solution was to use data that should come from real-time traffic. The second literature review is titled DDoS Attack Detection and Mitigation in SDN using Machine Learning. So this study encountered the issue of a higher number of DDoS packets in the dataset compared to normal packets, with this solution being to apply oversampling or undersampling to balance the traffic amount. Okay, the third literature review is titled DDoS Attack, Detection and Classification via Convolutional Neural Network or CNN. The study also faced a significant imbalance between normal and malicious traffic in the datasets, with the same solution as the second literature review, which is to apply oversampling or undersampling to balance the traffic amount. Okay, after discuss these previous studies, let's move on to chapter 3 with my friend Louis Dermawan.
In this chapter, we will explain in detail the approaches we took in this research. Before that, we will explain the aim of this research. Also, the aim of this research is to explain the use of machine learning algorithm to detect DDoS attacks. with the primary goals being to create a reliable and accurate model for DDoS attack detection to improve network security and resilience. Our research steps include defining the research topic, conducting literature review, selecting a dataset, and conducting experiment using the hybrid LR3 model to obtain results and conclusions. In our research, we use the CSE CIC IDS 2018 dataset, a collaboration between Communication Security Canada (CSE) and the Canadian Cyber Institute (CIC), which is the successor of CIC IDS 2017. This dataset includes 7 attack scenarios, which are brute force, heartbleed, botnet, DDoS, web attacks, and network infiltration. This dataset include network traffic and log traffic, which from each victim machine, as well as 80 network traffic filters extracted using CIC Flowmeter V3. During our research, we found that the dataset we used was imbalanced. Therefore, we employed Ardian, a method for addressing class imbalance problems in dataset by creating synthetic data from minority classes based on existing data distributions. This method focuses on data that is difficult to predict, which is useful for complex or varied minority data. We also applied min-max normalization, which is a filter normalization method that works by reducing linear coefficient in a data, which is used to change the vector value in filter into a format that is suitable for training. As mentioned earlier, we use hybrid machine learning model approach, which combines several models, which is logistic regression, random forest, and extractive classifier. Logistic regression is a statistical method for data classification analysis based on available information using the sigmoid function. The process begins by multiplying each input filters by its corresponding regression coefficient and then summing the result. The next one is random forest classifier. Random forest classifier is a method in the form of a decision tree that randomly takes new samples from the original data set and use this sample to build a number of classification decision trees. And the last one is extractive classifier. Extractive classifier is an ensemble algorithm for classification tasks, part of the random forest family. This algorithm builds several decision trees and combines their prediction. In contrast to traditional random forest, extra trees use random threshold for each filter instead of selecting the best fit, resulting in more diverse trees and more reliable final prediction. And the model we use is LR-trees. LR-trees is a method which combines logistic regression, random forest classifier, and extractive classifier. These models are selected based on their performance on the DDoS dataset. LR-trees use majority voting, where the final label is the most frequently predicted by the tree model. For example, if there are two target classes A and B, and two models predict A, while one model predicts B, then the final prediction will be class A. We also use the confusion metric to evaluate the performance of the classification model. The confusion metric displays the algorithm prediction result on actual data and includes information on true positive, true negative, false positive, and false negative. This method is also used to determine evaluation metrics such as accuracy, recall, precision, F1 score, which helps assess how well the classification model performs. All right, in chapter 4, we will discuss the result of the experiment we conducted. The dataset used consists of 1,000 entries, 1 million entries, which is 660 billion data and 380 malicious data. From this dataset, we selected 15 most important features out of 79 total features. We then split the dataset into 80 training data and 20 testing data. The training data was used to train a hybrid machine learning model that we developed called LR-trees. LR-trees is a combination of several machine learning models, including logistic regression, random forest classifier, and extractive classifier. The hybrid model we designed demonstrates the excellent performance in identifying DDoS attacks, achieving an accuracy of 99.99%, surpassing traditional machine learning models. Now, these models have proven to be effective in classifying DDoS attacks on the CSE CIC IDS 2018 dataset and is capable of accurately handling various attack scenarios, thereby reducing the false positive rate compared to traditional classification models.